Hello and welcome. Today we're going to talk about air pressure and that classic physics demonstration, the soda can crush. So what I have here is an empty, open soda can. I'll show you this one. It's just, the soda's been consumed, the can's open and it's empty, on a hot plate heating up with about 5 to 10 milliliters of water. Now the water is boiling in the bottom of the can, and the steam, which may be visible, is coming out through the top of the can. And in this demonstration, the can's picked up and put upside down into a bath of ice water, which I have here. So I'll put on my safety goggles, and I'll grasp the can firmly at the bottom with my palm facing up, and I'll get ready to upend it in the ice water. 1, 2, 3. And just like that, the can is crushed. And we can see that it's been quite well demolished, very well crushed. So while vivid and certainly one of the students' favorites as a demonstration, this is entirely qualitative. We can see the can is crushed, we can see the new shape, we heard the can crush, but we weren't really able to take any measurements. So what I propose to do is to do the same classic demonstration, empty open soda can with about 5 to 10 milliliters heating on the burner, on the hot plate, and in the meanwhile set up a data collection experiment here with my absolute pressure and temperature sensor, my data collection system, and my data collection software. So I have everything connected to the computer and I'm ready to collect absolute pressure and temperature data. A little bit more about my setup here. Connected to the absolute pressure and temperature sensor, I have this length of long hollow tubing, and it's probably nearly 1 meter long. And out at the end I have connected my fast response temperature sensor, which you can see right here. Now I've connected it just by twisting around these little twist ties, the kind you get on bread wrappers, and that keeps it connected to the end of the tubing. What I'm going to do is introduce it down into the can just before I put the can upside down into the water. All right, so I'll go ahead and begin recording pressure and temperature data. And we can see that we're at regular atmospheric pressure here, about 101 kilopascals. So just like before, I'll go ahead and grab the can with the tongs down at the bottom, and I'll introduce the tube with the temperature sensor about 2/3 of the way down into the can. And we can see, of course, that the temperature is increasing because it's down there near some boiling water. And here we go, into the water, 1, 2, 3. And crush. Now I'll stop recording my data. And we'll go ahead and scale the graph so we can see exactly what happened here, and I'll close the tool palette. And although I have several data points to the left between 0 and 30 seconds, at 30 seconds thereabouts is where the action seems to have occurred. And from this point, of course, I can go ahead and analyze my data. I can begin by dragging the axis either to the left or to the right. I could translate the entire graph to the left, which I'll do, so that I can stretch the x-axis just enough to give myself an idea of how much time it took for that phenomenon to occur. And you'll notice that my sampling rate is fairly high. I've been measuring data at the rate of 100 hertz, and I think you can see that because this phenomenon happens so rapidly, that rapid sampling rate is very advantageous. So there I have a little bit better look at the moment of crush, and I also see what happened to the temperature. So there we have it, an example of a qualitative can crush demonstration, and then a very easily adapted quantitative measurement-based can crush demonstration.